This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK and TRL Software.
Okay, good morning everyone. So today we're going to talk about this site here. This is the Hagley Road Terminus site on the Edgbaston extension of the Birmingham Tramway, and sort of some of these safety issues that we picked up as part of the design process which needed to be mitigated at the design stage. So our role in the Birmingham Tramway project, we're responsible for the design, the commissioning and the validation of the traffic signals. We are required to ensure that all the designs have produced the required quality, the required safety and also to programme. And we also present design solutions to the independent competent person and the safety verification team. And we're responsible for producing the traffic signal safety case for engineering. I think all the design disciplines on the project are required to produce a safety case for engineering. Now what the safety case for engineering includes is its risks that are identified by the design team and the safety teams at the start of and throughout the project. And we're required to provide evidence that those risks have been mitigated against. So your required evidence is things like your integrating calculations, your design documentation, your electrical testing certification, those kind of things. Now this document does need to be signed off by the independent competent person before the extension can be handed over to the tram operator. And the reason for mentioning this is that the Terminus site featured quite heavily in this safety case. Is this the thing? Here we go. So this is the Edgbaston extension. It runs from Centenary Square in Birmingham along Broad Street and then terminates at the Hagley Road terminus. The extension also runs under 5 ways underpass, and you can see that on the slide there. And there are 4 tram stops along the route. Now Broad Street is a shared section of tramway. This is where traffic and tram are run together and are unsegregated on the carriageway. Now, I'm not sure how many people have worked with trams, so I just thought it'd be worthwhile just giving a quick overview of the LRT operation at a traffic signal site. So typically there are 4 detectors along a tram route as it approaches the traffic signal control junction. We have the prepare detector, the advanced detector, the stop line detector and the clear detector. So in the traffic signal controller, a prepare detector input will often request sort of a ready stage for the tram. You know, maybe it's a stage where the LRT phase runs in, or there might be a demand-dependent pedestrian stage that needs to run before the tram signal is shown. So essentially, it gets the junction ready for the tram. The prepare detector typically won't be set up, to call the LRT phase. The advanced detector input, this is often configured to put in the LRT phase request, i.e. this is the input that where the proceed signal will be shown to the tram driver. The stop line detector, this has 2 functions. If the tram does not clear the stop line before the minimum green time or the influence period has expired, the stop line detector will put in a further demand to ensure that the tram doesn't get stuck. And once the stop line input has cleared, the LRT phase loses right of way and the intergreen timer begins. The intergreen will be extended until the intergreen delay maximum timer or the clear detector input has been triggered, and once one of these events is met, the controller reverts back to normal operation. So this is the Terminus site. It's obviously just a CAD plan. It's located on Hagley Road by 5 ways just outside of Morrison's. There's a scissor crossover at the site. I'm not sure you can see it there, but it's just by the number 2 on the slide, which allows the tram driver to select and change the platform. It's also used for operational purposes as well for the tramway. The site is quite complex in terms of its traffic signal arrangement, with a number of stages and phases in operation. And at the design stage, 3 safety issues were highlighted by the other design disciplines, the safety team and the independent competent person, which needed to be resolved during the design process. So these were shown by the numbers on the slide there. So the first one, shown by the number 1, tramways operate a line of sight policy, and as the tram exits a 5 ways underpass, there is a vertical gradient which restricts the forward visibility. So Hagley Road is a busy road on the Birmingham network, with traffic frequently queuing back onto 5 ways roundabout. And the lack of forward visibility as the tram exits the underpass means that the tram driver would not be able to see the queuing traffic on Hagley Road where the tramway intersects with it. The second issue, shown by the number 2, the Morrison's. So Morrison's has an egress within the junction, and this is also where the scissor crossover is located as well. How the tram points controller interfaces with the LRT signals at a scissor crossover created an issue which Dave will explain a bit more later on in the presentation. And the third issue is shown by the number 3. The safety team were concerned that drivers would drive into the terminus as they entered Hagley Road from 5 ways. So we're going to focus on how we assisted with the mitigation of these safety issues from an urban ITS perspective. So this picture here, this image is a photo of the tramway as it intersects Hagley Road by the Terminus site. You can see the underpass on there, and there's a picture on the bottom right there. Just gives you an example of the vertical gradient as traffic of trams come out of the underpass. This was taken before the tramway was built, but it does give you an indication of that vertical gradient as well as what traffic was like pre-COVID on Hagley Road. So tramways use line of sight operation, and as mentioned, this section of Hagley Road is notoriously busy, and as the tram exits the underpass, the tram driver would not have appropriate forward visibility due to the vertical gradient, and therefore wouldn't have sufficient time to stop at the normal speed of operation if traffic was queuing over the tramway. So we needed to mitigate this somehow, and what did we do? Well, first thing we did was we provided detection covering the section of Hagley Road where the tramway crosses it to detect stationary vehicles on the track. If a vehicle is detected on the track, the traffic signal controller is configured to inhibit the tram proceed signal until such time that the vehicle has cleared the track or that the driver has line of sight of any obstruction. Now, to ensure full coverage of the tramway where it crosses Hagley Road, we needed 2 detectors with configurable detection zones. Backup detectors were also provided in case of detector failure due to the safety critical nature of the operation. And if the detector and the backup detector fail, the proceed signal is inhibited until the tram gets to the stop line. Okay, so where the trams are at the stop line, that's when they're adjudged to have line of sight and the proceed signal can be shown. And we also configured the prepare detector input to demand an appropriate stage, which ensured that we stopped traffic from entering Hagley Road as the tram approached. So just got 3 examples now, just sort of showing how this operation works. The first slide here, it shows how LRT priority works when there's no stationary traffic detected over the tramway, so essentially normal priority resumes. The tram goes over the prepare detector, we get into the ready stage essentially. The tram goes over the advanced detector, that's when we show the proceed signal, and then the tram proceeds to clear the stop line. This slide shows how the LRT priority works when stationary traffic is detected and then moves off the tramway. So if there's queuing traffic detected on Hagley Road, when the tram activates the advanced detector, then the proceed signal will not be shown until the tram reaches the stop line. If the queue disperses and the tramway is cleared for a specified number of seconds, the proceed signal will be shown before the tram arrives at the stop line. So on the example here, we have traffic over the tramway when the tram goes over the prepare and the advanced detector, but that traffic clears before the tram gets to the stop line, so we're able to show the proceed signal. And the final example, it just shows what happens if traffic is detected over the tramway. The LRT proceed signal is inhibited until the tram gets to the stop line when it's adjudged to have line of sight, and then the proceed signal is shown.
So, as mentioned earlier, Morrison's have a delivery egress, and that crosses the tramway where the scissor crossover is located. And you can see the scissor crossover, that's the purple and blue lines just crossing there. This is used infrequently, but due to the conflict between HGV and LRT movements, this had to be signalised for safety, and that means the use of both traffic signals and LRT signals. So westbound trams proceed through the main junction to clear the conflict zone on Hagley Road, just mentioned by Shane, and then stop at the scissor crossover to select a platform. The tramway protocol is that if the tram overshoots the stop line at a scissor crossover, the points are to go into degraded mode. And this means that the tram proceed with caution, and it just shows a centre dot to the tram drivers. Now, this may have contradicted what the traffic signals were showing at the Morrison's egress. If the Morrison's egress traffic signals were showing a green signal as the tram is proceeding across the scissor crossover with caution, there could be a conflict, as delivery vehicles wouldn't expect to see an oncoming tram. So how do we mitigate this? Well, initially the points LRT signals were due to be controlled by the traffic signals, but as the point signals control whether the tram's in degraded mode, it was decided that it would be better for the points controller to control the LRT signals at this location, with the traffic signal controller controlling the tram signals and the traffic signals at the underpass. The Morrison's egress was configured as its own stream to allow this interface to be controlled independently of the main junction, and this solution required a complex interface between the traffic signal controller and the points controller. The points controller had to tell the traffic signal controller when it could show green to Morrison's, and the traffic signal controller had to tell the points controller when it could show proceed to the tram. So there was an intense and complex safety verification process carried out, and this required coordination between the traffic signal designers, the tram system designers, and the signal contractor. And this was to agree the inputs and outputs that needed to be shared between the two controllers for safe operation, and the procedures to be followed in the event of failure of either controller or the communications link between the two controllers. Agreement for these proposals was required from the independent competent person, and then the measures needed to be tested to ensure that they operated as intended. And there are some images from flow diagrams showing the complexity of this interface within the symposium notes. So, as you can see here with the staging plans, the Morrison's egress, it was configured as its own separate stream to allow this stream to be blacked out independently whilst the main junction signals remained operational. There's a constant handshake between the points controller and the traffic signal controller to control this stream, and this requires a constant input to show normal operation from the points controller. If the normal operation input is not received, the Morrison stream is configured to black out, and then if that points controller normal input is received again, the Morrison stream can come back online. So when the stream's operating normally, there's a demand for the Morrison's egress, demands the adjacent pedestrian crossing, which creates a gap allowing delivery vehicles to exit onto Hagley Road. If the points controller goes into degraded mode, the Morrison signals go into blackout and trams proceed with caution. Delivery vehicles may also proceed under caution, but they wouldn't demand the relevant clearance stage and they wouldn't be able to proceed potentially. So to resolve this, we installed the detector which covers the scissor crossover, and when that's occupied, that calls the pedestrian crossing, creating a gap, ensuring that HGVs can exit onto Hagley Road and don't sit over the tramway blocking the tram. There was also a request from the tram operator to include a low-level signal, which was a duplicate of the Morrison's, but it was decided that if this was in blackout, it'd be confusing to tram drivers, so this was excluded. As Shane said earlier, there was also a concern that drivers entering Hagley Road from Five Ways Roundabout would drive into the terminus, and so in order to guide drivers away from the terminus, there were several intervention strategies implemented. This included coloured surfacing, road markings and signage. And in addition, we implemented an ITS solution, which was the introduction of intelligent road studs, and these are shown by the arrows there. So these are provided by Clearview Intelligence, and they illuminate when the associated traffic signal is green for a short period afterwards, and then they de-illuminate after they lose right of way. And the aim of these studs was to provide dynamic lining, guiding drivers away from the terminus. And they've been provided at other sites in the UK, such as Switch Island and Sheriff Hall Roundabout. So what were our conclusions? Well, the signals were installed and made operational without the trams running in May 2022, and then the tram route was opened in July 2022. There was a long testing and commissioning process, and there was a month of shadow running of the tram, where we were able to, without passengers on the tram, where we were able to identify operational issues to resolve them. Validation of the junction was vitally important to ensure suitability of the timings, the tram timings, allow optimisation of junction operation and consideration of non-motorised users' requirements. And since undertaking validation, to our knowledge, there have been no significant issues with operational performance at the junction. The safety mitigation appears to be working, and feedback on how the junction's performing has generally been good. Thank you for listening.
Gentlemen, thank you very much. I did say, as I introduced these two, that there'll be a lot of lines on the screen for you to follow. I don't think I was wrong. Questions? That has to have provoked questions because it's used. Excellent. Ed, can we have a microphone in the middle here, please? Thank you.
Thank you, Robert Mansell Atkins. It's actually a question on the traffic signals. You kind of noticed as you go across the pedestrian crossing is in two streams, is it? And you've kind of got a straight across crossing rather than a stagger. So I just wonder, that's more a signals question. Does that cause any confusion or problems, or do pedestrians get that they have to wait for the second crossing okay?
No, I think there's sufficient space, isn't there, vertically between the two crossings, so it's quite clear there's separation. And was it previously like that before? It's an existing site where there was that arrangement previously, so it wasn't really a problem. And apart from anything else, the pedestrians at that site just don't use it, walk wherever they want. There's kids up and down across the tram lines everywhere, so it's not been a significant issue.
Any other questions? I'm going to ask you one then, while people are thinking. I'm part of the team that are rewriting the Topaz spec for tram signals. Yeah? And I got sent a photo, and I won't say which authority it came from because that wouldn't be fair, but it was a points indicator signal. And I can't find reference to it in any documentation anywhere. Still can't hear me, sorry, right. Yeah, after talking a lot last night, it's my voice and my arm. So in the process of trying to redraft the Topaz spec for tram signals, I've come across something called a sort of points indicator. Yeah. Can't find any definition of it anywhere.
Yeah, that's used by the signalling engineer on the rail side of things.
And that's what I thought. May I talk to you about that afterwards?
Yeah,
because I'd love to make sure we've got that covered. Yeah. Thank you. So that's a really nerdy little detailed question from me. What would you expect otherwise? Any more questions? No? Well, in which case we're going to get to coffee early. Gentlemen, thank you very much indeed for a fascinating presentation. Thank you.